We're supposed to solve this problem. A soldier in lookout tower A spots an enemy at a direction of 40 degrees. Okay, let me start with that. Now, I'm going to put soldier A right here. And when it says he spots an enemy at a direction of 40 degrees, I wish it actually was very specific, but we're going to assume that he actually is measuring with a compass. And so he's actually measuring 40 degrees from north. So this is north, which 40 degrees from north would be like right about there. So he's actually looking this direction. Okay, we don't know how far he's got to look. He's looking just somewhere that direction. Okay, then it says a soldier in lookout tower B, which is exactly 28 miles east, directly east of the tower A. And of course, if this is north, let me just draw this. This is north. This is east. This is south, and this is west. I always say never eat shredded wheat. Some people say never eat soggy waffles as you start, up, directly up, and then it goes around. So the other soldier in tower B is directly east, which would be this way. So if we go this way, 28 miles, I'll just call that 28 miles right there. And this is where soldier B, or lookout tower B, is at. Okay, and this soldier over here in tower B spots the same enemy at a direction of 330 degrees. Again, he's using a compass, and so that's measured from north. So if this is north this way, 330 degrees would actually be going around this way clockwise, somewhere like around here. So he's actually looking that direction-ish. Okay, somewhere like that. And so that's 330 degrees. In fact, let me label this one was what? This one was 40 degrees. All right, well, first off, here's the enemy. Let me put a big purple dot there. There's the enemy. And what we're trying to do is figure out how far from tower A is the enemy. So it's actually this distance over here. But I notice there's a big old triangle here. Let's fill in some information, and then let's redraw the triangle. So if this is 40 degrees from north, but this guy is going directly east, that's technically 90 degrees right here, now 90 degrees is from north to east, but that leaves inside my triangle 50 degrees. If this is 40 degrees, that leaves 50 degrees to finish. Whoops, I almost put 90 degrees when I was saying it. This is 50 degrees in here because together with the 40, it makes a full 90 degrees from north to east. Similarly, over here, 330 degrees is almost all the way around. So that actually just leaves 30 degrees in this little spot, but that's actually not in my triangle. So what would be in the triangle? This remaining piece, and again, here's another 90 degrees. From north to west is 90 degrees. So 30 degrees there leaves me 60 degrees in my triangle. So actually, let me just redraw this triangle over here. Doesn't even need to be so big. I just need it to visualize and keep track of everything. I just drew it almost like an isosceles, but it's not. Here's the enemy. Here's soldier tower A. Here's B. And we know this distance here was 28 miles. I'm just copying down the key information here. And in fact, the angles in my triangle, this is 50 degrees in here. This was 60 degrees over here. And actually, if I add those together, what is that, 110? I even know that this is 70 degrees because it finishes off 180 in a triangle. Now, what are we trying to find? We're trying to find how far from tower A is the enemy. Well, here's tower A, and the enemy is over here. So the distance we're looking for is actually this distance, this length. Okay, now let me just label that with X. That's the distance we want. Because actually, I want to use my highlighter to do this. I notice on this triangle, it's not a right triangle, but I can use some tools that we have. Since I know this complete pair, the angle and the side across from it, it can help me finish another incomplete pair, and this is what we want. We want this side, so I'm going to use this angle across from it. I can use the law of sines to finish this problem. So let me just get a little more space here to do my law of sines. So law of sines, actually, I'm used to normally doing it like sine of A over A. In fact, watch as I start to write this out. I could do sine of 70 degrees over the 28 equals the sine of the 60 degrees over the side I'm missing. Notice here the missing thing is on the denominator, which is not a big deal. I can multiply both sides by x and then do some solving. But actually, there was an alternate version where I can just flip this. I can actually just do 28 over sine of 70. And that ratio is just going to be the flip of this ratio. Since they're both just fractions, I can actually just flip them. All right, so there we go. Here's the version I'm going to use, because this one's actually pretty easy to solve. For this one, I can actually just multiply both sides. Let me zoom out a little bit here so I got some room to write it. But I can actually just multiply both sides by the sine of 60 degrees. Sine of 60 degrees. And then this would be my answer. X would actually just equal whatever I get when I take the sine of 60 degrees and I multiply it with 28 over the sine of 70 degrees. And so I just need to calculate that. Okay, and I've already calculated, but let me just kind of show you, because this can be a little bit of an annoying thing to type in. First off, when you type it in, let's just make sure our calculator is in degrees. Good. And then I can just go sine of 60. And I got to multiply with the 28 that is divided by the sine of 70. And there we go. There's my answer. What is it? About 25.8. So 25.8. I'm going to write that down. So x is approximately 25.8, and of course these are miles since my situation was in miles here. But it actually says rounded to the nearest mile. So 25.8 is actually about 26 miles. So there's my answer for this. That distance is 26 miles. I could even put it over here in my original picture. This is 26 miles from Tower A to the enemy. Now let's try another problem here. All right, this one says you're hiking and trying to determine how far away the nearest cabin is, which happens to be due north from your current position. So looking at this picture, here's a cabin straight north up above in north direction. So this must be me. So this is me right here. This must be my buddy, because it says a partner walks 220 yards due west from your position. So they walk over there. There they are. This is the partner. And they take a bearing on the cabin of north 29.9 degrees east. So if they went straight north, that would be straight up that way, but they actually do 29.9 degrees east from north. And so there's the angle. It says, how far away is the cabin to the nearest yard? Now, I assume they're saying how far away is the cabin from me. So I will call it this distance x. This is what I'm looking for. I don't care how far away it is from my partner. So I assume it's from me. So let me actually just kind of fill in something else here. If that's 29.9 degrees from north, remember there's north straight up, but I am to the east, they are to the west of me. And so that's 90 degrees. So how much is left from the 90 degrees? What would that be? That would be 60.1. Yeah, because that's almost 30 degrees. So it would actually just be 60.1 degrees. So let me just redraw this triangle real quick. I got just basically a triangle. I'm over here in the right angle. I'm looking for this distance here. We know this bottom distance of the triangle is 220 yards. And we know the degrees inside the triangle is 60.1 degrees. This is actually just a pretty, simple right triangle problem to solve. With this angle here, it's opposite and adjacent. That sounds like a tangent problem. So the tangent of 60.1 degrees is actually just equal to opposite over the adjacent. And then it's pretty quick to solve this one. Just multiply both sides by 220. And then that solves this. And so yeah, x is going to equal whatever I get when I take 220 and multiply it with the tangent of 60.1 degrees. And so let's crunch that. Again, it's always important to make sure your calculator is in degrees, especially when you fire up a new instance of your calculator. There we go, we'll go degrees. So I just gotta go 220, multiply with the tangent of 60.1. And there's my answer. It's about 382.59, or let's just say 382.6. So about 382.6. But even here it says to the nearest yard. So that would actually just be about 383. 383, and these are yards because that's the units that they gave it to me in. So there we go. The distance from me to the cabin is 383 yards.